There are many real-life applications of trig functions, so let's explore a few of them. It's suggested that the height h of t meters of the tide above mean sea level during a particular day at sea break is given approximately by this rule right here. T is the number of hours after midnight. Okay, so t is equal to 0, obviously is midnight. Draw the graph of y equals h of t between 0 to 24. Okay, to do that, what we're going to need to note is that the amplitude is 5, that the period is 2 pi over pi on 6, which is going to be 12. All right, and that means that the scale is going to be 12 on 4, which is 3. All right, so let's get sketching. So it's a sine function, so sine starts at 0, we'll go up to 5 after 3, down to 0 at 6, down to -5 at 9. There it is there. 12, there's one cycle. And then we'll just do a second cycle. So 15 is the max, 18, back down again. 21 is the min, 24, back to the mean line. Right, so there's our model. All right, now let's see here. So when was high tide? So from the graph, you can quickly see that it's going to occur at 3 and 15. All right, so this one here, when was high tide? We're going to say 3 a.m. because that's 3 hours after midnight. And this is going to be 15 hours after midnight. So that is going to be 3 p.m. What was the height of the high tide? 5 meters. What was the height of the tide at 2 a.m.? Okay, so height of the tide at 2 a.m. So that is going to be this height here. All right, so to do that, what we're going to do is h of 2. All right, and that's 5 sine 2 pi on 6. Now 2 pi on 6 is pi on 3, so it's the sine of pi on 3. So h of 2 equals 5 lots of the sine of pi on 3 root 3 on 2. So it should be 5 root 3 on 2. So the height of the tide at 2 a.m. was 5 root 3 on 2 meters. Okay. All right. What about 2 p.m.? 2 p.m. is that's 14 o'clock. That's going to be exactly the same. Okay. So that will also be 5 root 3 on 2 meters. Okay. And of course, what you're going to do is put 12 in here, which is going to come out with exactly the same value. A boat can only cross the harbour bar when the tide is at least 2.5 metres above mean sea level. When could the boat cross the harbour on this day? All right, so what we're looking for is, so this is 3, this is 2.5. So we're looking for when the tide is above 2.5 metres. Okay, so that's where we want the tide to be. And it's in this time here, or in this section here, when the water is this height, that I'm able to actually cross the harbour bar. Okay, so when could the boat cross the harbour bar? Well, it's when h of t equals 2.5. All right, so let's try that. So we're going to go 2.5 equals 5 sine, what's the function again? Pi t on 6. All right, so if we divide both sides by 5, I get 2.5 over 5, which is actually a half. All right, now when is sine a half? Okay, so it's going to be here at pi on 6, and over here, which is 5 pi on 6. So that's going to be our first two results. And then we're going to generate another two results. So we're going to go, we're going to say this, we've got pi t on 6 equals pi on 6, 5 pi on 6, and we're going to add 12 pi on 6 to both of these solutions. So it's 13 pi on 6 and 17 pi on 6. All right, now what we're going to do is for each of these solutions, we're going to divide them by pi on 6. All right, so what's going to happen is pi on 6 over pi on 6, that's just 1. 5 pi on 6 over pi on 6 is going to be 5, 13, and 17. All right, so what does that mean in context? A boat can only cross, so this is when the height will be 2.5, so at time 1 and 5. So let's get that in terms of the answering the question. So boat can cross between 1 a.m. and 5 a.m. So that's those two times, because between those two times, we are above 2.5 meters. And the other time it can happen, and this time here 13, so that's 1 p.m. and 5 p.m. All right, so there it is, done all by hand. Okay, and this can be very quickly also done on the calculator. So I'm going to show you how to do that as well. So if this was a calculator question as well, we'll define the function. So f of x equals, what is it? 5 sine I usually have a quick look at it to make sure it looks like I want it. Looks good. Okay, so when was high tide? So what we would do for high tide is I would go solve f of x. When is f of x equal to 5, which is the high tide from the graph? Solving for x, please, but because it's a trig function, I need to give it a domain between 0 and 24, so over the first 24 hours. And we've got 3 and 5. All right, what was the height of high tide? So to get that, I would do f of 3, which is when high tide occurs, get a height of 5. What was the height of the tide at 2 a.m.? That would be f of 2, 5 root 3 on 2. Did I get that? Yes, I did. Good sign. 2 p.m, f of 14. And finally, a boat can only cross the harbour when the tide is at least 2.5 metres above mean sea level. Solve f of x equals 2.5 for x, please, between 0 less than x less than 24, and it will give us exactly those times that we solved by hand. So there's how we would do all those questions on the calculator. It's very quick on the calculator. All right, so here's another one. A temperature T degrees Celsius in a town over a day is modeled by that function with that rule. Okay. So what do we know? Amp is 8. Period is going to be 2 pi over pi on 12, which is 24. Scale is going to be 24 over 4, which is 6. All right, 17 is the vertical translation, so that's going to be the mean line. All right, so there's going to be a line going across here at 17, which is the average value of the function. Now, it is cosine. So cosine starts up typically, but because it's negative, it's going to start down. So we're going to go to 17 take away 8 is 9. So we're starting at 9. Okay, and the next key feature is at 6. What it's going to do is cosine is going to go up to the mean line. Then it's going to go up to the max value, which is 17 plus 8 is 25. And where is it? It's going to be at 612. There. All right, and then it's going to come back down again. So at 12, 18, there's 18 there. And then 24, it's going to revert to the min value. All right. All right, there is my very jittery looking cosine model. Okay, so don't forget, girls, that you want to sketch all key features or label all key features. 0, 9. The max value or the turning point is going to be 12, 25, and this endpoint here is 24, 9. I don't think I labeled the key features on this graph here yet. Can you just update your graph on that with all the key features? Okay, what is the temperature at midnight? So midnight is, model rule, the rule, T is time in hours after midnight. So at midnight, that was going to be when lowercase t is equal to 0, okay, or the initial value, that's going to be, in this case, 9 degrees Celsius. What are the maximum and minimum temperatures reached? Min is 9 degrees, max is 25 degrees. At what times of the day to the nearest minute are temperatures warmer than 20 degrees? So there and there are my two values. Okay, so to do this one, I will let t equal 20 equals 17 take away 8 cosine pi t on 12. That's going to be 17, so 20 take away 17 is 3. That's going to be negative over 8 cosine pi t on 12. Now, this one here, once you get to this point here and you note that this value here is not one that you know an exact value for, then you know that this is going to be a calculator question. So let's do it. We're going to solve 17 take away 8 times cosine shift pi times x over 12. When that is equal to 20, what are we letting it equal? 20 for x over the domain 0 less than x less than 24. All right, so the exact value are these ones here. So let's approximate those ones. Okay, so it's going to be 4, 6, 8, 2, 8, dot, 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 dot. T is equal to 16.5317, dot, dot, dot. Now that seems right in context. Yes, 7 and 16 odd. Yep, so that matches up really nicely with my dodgy graph, which is even more amazing. All right, so at what times of the day? So this needs to be put into a time. So this is going to be 7 hours after midnight. So that's 7. So at 7. Now this is not 7:47 because what we're going to do is take this decimal component, and that is a fraction of an hour. That is 0.468 of an hour. So an hour is 60 minutes. So we need to multiply that through by 60 minutes, which means to the nearest minute, that is 7:28 a.m. And 16 is going to be 4. Let's grab the decimal component, which will be a bit over halfway through the hour. So grab a few of the places and multiply that by 60 as well, and you get 31.9 to the nearest minute is 4:32 p.m. All right, so at 4:32 p.m. in the afternoon, or between 7:28 and 4:32, your temperature is above 20 degrees. Okay. On an adventure park ride, riders are strapped into the seats on a platform that starts 12 metres above the ground and goes up and down. The distance h of t metres on the platform above the ground t seconds after the ride can be modelled by this. So sketch the graph of the ride over one cycle. Sure. Amp is 5. Period is 2 pi over pi on 3 equals 6. Now note that with many applied problems that this horizontal scale is a number without pi in it because that's much more relatable. Okay, so mean line is at 12, so that will be there. Amp is 6 and it's a sine function, so period is 6 rather. So we're going to go 6 over 4 to get the scale, which is 3 on 2, which is 1.5. Okay, let's get stuck into it. So here's 1, here's 1.5. So the next key feature happens at 1.5. And what is the max going to be? 12, 17. It's going to be 17. All right, and then 1.5, then that is going to be 3. We're back to the mean line. And then 4.5, is it? 3, 4.5, yeah. And the min is going to be 12, take 5 is going to be 7. There it is there. And then 4.556 is going to be back to the mean line. All right, so here is one cycle of this really exciting ride. All right, make sure those curves of yours are nice and smooth, girls. So 0, 12, 1.5, comma, 17. This turning point here is 4.5, comma, 7, and 6, comma, 12, back to the mean line. Okay, all right, we've got our function. According to this model, what is the maximum height above the ground reached by the platform, and after how many seconds does this occur? So there is the maximum value. So the maximum value is 12 plus 5, so 17 meters at 1.5 seconds. During a ride, what proportion of the time is the platform at least 10 meters above the ground? So here is 10 meters. Okay, so this portion of the ride, it's going to be above 10 meters. So basically, if we work out the x value there, we can say that it's this amount of time for which it's above it. So what we're going to do is ask a question of the function, which is h of t. We're going to say, hey, h of t, when are you equal to 10? All right, and that's going to give us a result, and then we're going to interpret that answer. So jump onto your calculators, define your function. This is a good habit to get into, is defining your function, because Methods Exam 2, you're going to work on this function, or usually work on a function for several parts of a question. So it's worth actually getting that definition done nice and early. Now, what's your variable use here? I've spent countless hours of my time trying to problem solve or work out what I'm doing wrong, whereas I've mixed up a variable somewhere. So just be careful. So h of t is equal to 10. So I'm going to solve f of x equals 10 comma x. Now remember, it's going to give you a general solution, but all you do is you have a look at your graph and you tell it where to go hunting. So I know that it's going to equal 10 between here and say here, so I'm going to give it, tell it to hunt between 2 less than x less than, let's go 5. No, we'll go 4.5. Okay, and there it is there. All right. Now, why I said 4.5 is what it will do is dip above 10 at about 6. So if you give it the full domain of 6, you're going to get a second solution in, and we don't want that solution. In fact, do we? Yes, we do. During a ride, what proportion of the time is the platform at least 10 meters above the ground? All right, different strategy. All right, so what I'm going to do is actually work out for how long the ride is below 10 meters. So I'm going to work out how long this happens below 10 meters. Now, once I've got that, what I'm going to do is remove that from the cycle of the ride, which is 6 seconds. All right, so what I'm going to note is that t is equal to 10. So I need to give a domain over which I'm solving for, where x is an element, where t is an element, between 0 to 6. So I'm hunting between 0 and 6. You can include, exclude, it doesn't really matter. I'm just saying that these are the acceptable values of t. T is equal to 3.39 ... T is equal to 5.607 ... All right, so to get this duration here, what I'm going to do is remove 3.39 from 5.6. Let's grab this value here. Take away this value here. Now, again, note that I'm using the most exact value I can find. So that means it's below 10 for 2.2 seconds. Now we're going to do 6, take away the answer, so whatever's in the answer slot, which means that, so above 10 meters for 3.7859 ... seconds. Okay, and that is our most exact answer that we can provide. Really, if this was an exam 2, what we would have got you to do is approximate to 2 decimal places or something like that. So yeah. All right, we'll work one more example. I think the movement of a skateboarder on a parabolic ramp can be modeled by this equation. Okay, so let's see what this skateboarder does. Starts at a height of 3, but this is a cosine function. 3 plus 2 means skater starts at 5. All right, now the period is going to be 2 pi over pi on 20, which is 40. 40 divided by 4 is equal to 10, so my scale is 10. Okay, so it's cosine, so cosine starts high, so that's going to start at 5. What it will do then is dip down to the mean line, which is at 3. Then at 20, it'll be at its lowest point. So that's going to be at 1. Is that right? Yeah, 1. We've got the mean line at 3. Take away 2 is 1. Yep, that sounds good to me. Back there and back there. So there is one cycle, and they want 2 periods of this. Okay, so we'll just do a second one via symmetry. All right, let's see what this skater does. Okay, so goes down and up, and has another pop at it. Okay, so again, excuse the wobbly graph. Let's label all key features. So 0, 5, 20, 1, 40, 5, 60, 1, endpoint 80, 5. What's the height of the skateboarder after 10 seconds and again after 50 seconds? All right, so let's see if we can get, so this may or may not be an exact value. 10 on 20 is pi on 2. I think it is going to be an exact value. So let's just define it on the calculator and do that. So define f of x equals 3 plus 2 times cosine shift 0 times x on 20. All right, so time after 10 seconds, I'm pretty sure that this is going to be exact, yeah. So we're going to say that, what's the height of the skateboarder after 10 seconds? T is equal to, H is equal to, sorry girls, height is equal to 3 meters and H equals, let's do F of 50, which is also 3 meters at 10 seconds and 50 seconds respectively. Does your result from part B give an indication of the period? Show another calculation for the period. So it does, because what happens is, if you note that 10 seconds and 50 seconds is 40 seconds apart, what should happen is every 40 seconds, the person should be at exactly the same point. So we could do another quick calculation on the period by feeding it these same heights, no matter what the height is. So if we go and say the height at 12 seconds and 42 seconds, all right, what we could do on the calculator is just go 12, and that's 2.3 meters, 2.38, and it's got to be the same height at not 42 seconds, 52 seconds. Should be exactly the same height. Okay, so no matter what the times are, as long as they are 40 seconds apart, they will give you exactly the same height. I'm not sure exactly what it means by show another calculation for the period, but the basic way I would do it is how I would sketch the graph, which is pi on, what was it, 20, I think, which is going to be 40. In the first minute on the ramp, when does the maximum height occur and how high is the maximum height? So we're going first minute, okay? So T is the time in seconds, 60 seconds is a minute, and the maximum height occurs at 0 seconds, so the initial value, and 40 seconds. What was the max? 5 meters. All right, so we've got another example here, but I think what we'll do is stop now at 4 examples and get you to hit the exercise.